solve the first problem of the first partial exam of electricity and magnetism that says like this. A charge minus 2q is at 0.0, so here, and another charge plus 6q is at minus 3, minus 5, so minus 5, minus 3, so here, plus 6q. Find the coordinates for a third charge to be placed on the line joining these two. And so the force on the third charge is 0. So we have here charge 1, and here we have charge 2, and we have to find a third charge. So if we put here a third charge, we will obtain that this charge 1 is positive, and this other charge here is negative. If we put here a charge, this one will push, and this other one will pull, but will be smaller. So the difference will not be equal to 0. So it can be here. If we put it here, this one will push, and this one will pull, so it won't be equal to 0. And if we put it here, this one will push, but not as much as in here, and this one will pull, but in an average amount, because this one is bigger than this one. So here maybe it will be a right place to put it. This one, it's the origin. Oh no, well, here is not the origin, but here we are going to take it as our x0, and here we will have our x2, here we will have x1, here we will have x2, and here, from here to here, we will have x3. Okay, for finding the value of x2, we will obtain that it is the square root of the parts of this triangle, okay? Because we know that this part is equal to 3 and this part is equal to 5. So we will have that it's the square root of the square of minus 3 plus the square of minus 5, and this will be equal to the square root of 34, that it's equal to 5.88, because it's the square of this one plus the square of this one, the square root. Okay, so once we know this distance, we know that for this special point we want to be 0, so we will have to get that the distance from the force from 1 to 3 will have to be the same as the force from 2 to 3. And for doing this, we know our formula, Coulomb's law, that says that our Coulomb constant times the charge 1 times our charge 3, charge 1, charge 3, over the distance from 1 to 3, that is this one, square, has to be equal to this part, that it's our Coulomb constant times the charge in 2, the charge in 3, over, here it will be different, because we know the distance in 2, we know the distance in 2, but we don't know the distance in 3, so we will have to put the square of the distance in 3 minus the distance in 2. So, as we know, the constants go, the charge 3 goes away, and we are left with the charge in 1 over the distance in 3 squared equals to the charge in 2 over our differences of distance squared. For solving this, we know that the charge 1 is equal to 6 and q, and this one is equal to minus 2q. Okay? Once we know this, we can solve this equation by saying this times this is equal to 2x3 squared, and this times this, it's easier because it's 2. It's this times this is this, and this times this is 3 times dx squared minus 2x3 plus x squared. That is exactly this one, but it's solved, and this one it's equal to x3 squared. Okay, once we have these two values, we can sum them up, and we will obtain that the one of the top will be equal to this one, that is 2x3 squared minus 6x3 x2 plus 3x2 squared. That is exactly this part here. It's equal to 0, and we will have that this value here, well, no, not this value here, this value here and this value here, it's equal to 5.88. So if we put 2x3 squared minus 6x3 times 5.88 plus 3 times 5.88 squared, this part times this part will be equal to 34.985, and this part will be equal to 102, equals to 0. Okay, once we know this, I'm going to write it down here. Once we know this, we can solve here. The only missing variable that we want is the x3, and so we can solve it, and we will obtain two values for x3. These two values for x3 is 13.8 and the other one is 3.7, but the highest one is this one, 13.8. So we are going to take this one because it's the highest one, and we want the one that is higher than the charge 2. And once we know it, we want now to calculate exactly the coordinates. So we know now the distance, and we know we want to calculate the coordinates. Once we know the distance, I'm going to we want to obtain this angle here, that will be exactly here. It's our charge 3, this angle here will be exactly the same as this angle here. And for obtaining the coordinate, we need this angle here. And this angle here can be obtained with this angle here. So this angle here, it's the tangent of this, it's the tangent of these two cathets. So we know that it's -3 over -5, that it's equal to 30.96. So theta, that it's, well, if this one is 30.96, then theta will be equal to 59.04. So once we know the value of theta, we want to obtain the coordinate in x and the coordinate in y. So the coordinate in x will be exactly the distance 13.8, that we know that it's the distance here, x3, 13.8 times the cosine of theta, that was 59.04, and this will be more or less 7, and the y will be 13.8 times the sine of 59.0, that will be more or less 11.84. So the coordinates for the charge 3 are 7, 11.84.